What if you could leave Earth behind and embark on a journey across the cosmos, not in a spaceship, not yet, but through the eyes of humanity's greatest explorers, our robotic pioneers? These machines built by dreamers and scientists have braved the deadly void of space to uncover secrets that reshape how we see our place in the universe. Today, we're taking you on an epic adventure from the rusty plains of Mars to the icy edges of our solar system and beyond to the stars themselves. Buckle up, this is a cosmic odyssey exploring the solar system and beyond. You won't want to look away because every moment reveals a new wonder, a new question, and a new reason to dream big. Let's dive in. Space has always been humanity's ultimate frontier. From ancient stargazers charting constellations to modern astronomers peering through telescopes, we've been drawn to the unknown. But space is no friendly playground. It's a brutal environment, and temperatures plummet to near absolute zero. Radiation can fry electronics and cells alike, and the vacuum ensures no second chances. Humans can't survive out there, but our curiosity refuses to be grounded. That's why we built spacecraft like the Voyagers rovers, like Curiosity, and orbiters like Cassini. These machines are our proxies, our ambassadors to the stars, carrying our questions into the void. Let's start with Mars, the planet that's captured our imagination more than any other. Why it's close, it's rocky, and it feels tantalizingly familiar. Billions of years ago, Mars wasn't the barren desert we see today. Scientists believe it had rivers, lakes, maybe even oceans. Picture this, a young Mars wrapped in a thick atmosphere of carbon dioxide holding warmth and water like a cosmic cradle. Rivers carved valleys, and liquid water pooled in vast basins. But something went wrong. Mars' magnetic field, unlike Earth's, was too weak to fend off the solar wind, a relentless stream of charged particles from the sun. Over millions of years, this solar assault stripped away the atmosphere, leaving Mars cold, dry, and exposed. Today, its surface is a graveyard of ancient rivers marked by dust and frost. This isn't just a science lesson, it's a cautionary tale. Mars shows us how fragile a planet's habitability can be. Earth's magnetic field shields us from the same fate, but understanding Mars helps us appreciate our own planet's delicate balance. It also fuels the dream of one day walking on Mars, maybe even terraforming it. Could we make Mars green again? That's a question scientists and visionaries like Elon Musk are tackling, and we'll explore those ideas later. To understand Mars today, we need to go beneath its surface. Thanks to NASA's InSight mission, which landed in 2018, we've peeked into Mars's interior like never before. Imagine a planet sliced open at its core is a massive ball of iron, nickel, and sulfur, roughly half the planet's radius. This core is hot up to 2000 Kelvin, but mostly solid due to immense pressure. Unlike Earth's liquid outer core, which generates a protective magnetic field, Mars' solid core can't sustain one. Surrounding the core is a molten mantle layered with metal oxides at the bottom and silicates higher up. Above that lies a crust averaging 50 kilometers thick, much thicker than Earth's oceanic crust, but similar to our continents. The northern hemisphere's crust is mostly andesite, while the south is basalt, hinting at different geological histories. This internal structure explains why Mars lost its atmosphere. Without a strong magnetic field, solar wind eroded the planet's protective blanket, letting lighter gases like oxygen escape into space. What's left is a thin, dusty atmosphere, barely 1% of Earth's pressure. But the surface tells a richer story. Take Valles Marineris, a canyon system stretching over 4,000 kilometers along Mars's equator, longer than the United States is wide. It's like the Grand Canyon on steroids, carved by tectonic forces and possibly ancient water flows. These valleys resemble Earth's river deltas, like those of the Nile or Amazon, suggesting water shaped Mars's surface billions of years ago. Let's pause for a personal reflection. When I first learned about Valles Marineris, I was struck by its scale. It's not just a geological feature. It's a testament to a lost world. Imagine standing on its rim, gazing across a chasm so vast it dwarfs anything on Earth. It's humbling, but it also sparks curiosity. What else is out there? Missions like NASA's Perseverance rover are searching for answers, hunting for signs of ancient microbial life in places like Jezero Crater, where a river delta once flowed. Every rock they analyze, every sample they collect brings us closer to knowing if Mars was ever home to life, or if it could be again. Now let's zoom out to Saturn, the jewel of our solar system. Its rings made of ice and rock are a cosmic masterpiece visible even through backyard telescopes. But Saturn's moons steal the show. Titan, larger than Mercury, has a thick atmosphere richer in nitrogen than Earth's. It's the only known body besides Earth with stable surface liquids, lakes of methane and ethane. Then there's Io, a moon of Jupiter, not Saturn, a clarification from the original with volcanic eruptions so intense they'd make Vesuvius blush. These moons, explored by probes like Cassini and Voyager, show how diverse our solar system is. Here's a real-life story to bring this home. In 2005, the Huygens probe, part of the Cassini mission, landed on Titan. Scientists at the European Space Agency waited anxiously as data trickled back. When images revealed a landscape of methane rivers and lakes, it was like discovering an alien Earth. One scientist, Carolyn Porco, described it as the most exciting moment of my career. That moment wasn't just about data, it was about humanity reaching out to touch another world. Titan's chemistry could hold clues to how life began on Earth, and studying it feels like reading the universe's recipe book. But let's talk about the Voyagers. Launched in 1907, Voyager 1 and 2 were designed to explore the outer planets. They sent back stunning images of Jupiter's storms, Saturn's rings, and Uranus' pale blue haze. Voyager 2 even gave us our only close-up of Neptune's stormy atmosphere. These probes didn't stop there. They kept going, carrying golden records with sounds and images of Earth, a message to any intelligent life that might find them. Today, both Voyagers are in interstellar space, over 15 billion miles from home, still sending faint signals. They're a testament to human ingenuity built with 1970s tech, yet outlasting expectations. At the solar system's edge lies Pluto, a world redefined as a dwarf planet in 2006, but no less fascinating. NASA's New Horizons mission, arriving in 2015, revealed a landscape of nitrogen ice plains and towering mountains. Pluto's heart-shaped Tomball Regio became an instant icon, a reminder that even distant worlds have character. But Pluto's story is also personal. For Alan Stern, the mission's principal investigator, New Horizons was a 25-year labor of love. When the first images arrived, he said it felt like meeting a new friend. That emotional connection drives science curiosity isn't just intellectual, it's human. Pluto marks the boundary of our solar system where the sun's influence fades. Beyond lies the heliopause where Voyager 1 crossed into interstellar space in 2012. This is uncharted territory where solar wind meets the cosmic rays of the galaxy. The Voyagers are our first scouts here, measuring magnetic fields and particles in a realm we can barely imagine. Their data challenges our models of the universe, showing how little we know about the space between stars. Now let's dream bigger. Alpha Centauri, Our closest star system at 4.37 light-years away is a triple star system with Proxima Centauri, the nearest star to Earth. Could we ever reach it? The Voyagers traveling at 38,000 miles per hour would take 80,000 years to get there. But new ideas like breakthrough star shots, laser-propelled nanocrafts, aim to cut that to 20 years. These tiny probes, no bigger than a smartphone, could one day beam back images of alien worlds. It's speculative, but it shows our ambition to push beyond our solar system. Reflecting on this, I'm reminded of Carl Sagan, who championed the Voyager program. He saw space exploration as a way to unite humanity, to remind us we're all on a pale blue dot. That perspective humbles me. It makes our differences seem small compared to the vastness of the cosmos. Whether we're exploring Mars or dreaming of Alpha Centauri, every step forward is a step toward understanding ourselves. Our journey from Mars to the stars reveals one truth. Exploration is who we are. Every probe we launch, every image we capture is a testament to our refusal to stay still. The lesson: don't just look up, act. Learn about the universe, support science, or simply share a starry night with someone you love. The cosmos isn't just out there, it's a mirror reflecting our potential. Keep exploring, keep questioning, and let's see how far we can go together.